Hello everyone, I'm Lingye Zhang. I'm so glad to present my work to you. My study is about fabrication methods and design outcome. The construction of models is an important component in the innovation and final production phase of a design project. They are the key to testing concepts to identify and correct design or usability problems. Models at each stage of the design process accurately represent the concept, and so it is important to choose fabrication methods that are appropriate for the growth of the model. The focus of this paper is to the relationship between the fabrication method used for model construction during the design process and the perceived success of the final design outcome. I will introduce the background first. In the background in this study include design process, different kinds of models in design process, and different fabrication methods to make models. Product design is the process of creating a new product. It's not a simple process. Each good product is evolved over time through many days of research, analysis, design studies, engineering, and prototyping, and finally testing, modifying, and retesting until the design has been perfected. Simplicity. The design process is figure out what is required. Brainstorm possible ideas, creating models, evaluating the design, and then generating the product. These 5 processes corresponding to 5 stages, which are defined, indexed, prototyped, evaluate, and build. Design process is not a one-time process. Designers need to repeatedly execute the idea, making it into physical model, and then evaluate its success by seeing if any improvements are necessary. After all the problems are solved, the final product can be built. So, during the prototype and evaluate stages, a number of models are built and tested. Now, I'm going to talk about these models. There are many different types of models. They can help designer adjust in design, materials, size, shape, assembly, color, manufacturability, and strength. Most of them are not made as same as the final product because they have different aspects to test. For example, a model can be as simple as some sticks instead together, which has low visual fidelity. However, this no visual model can show the construction very well. Contrarily, a perfect appearance 3D print model, which looks exactly the same as the final product, has a high visual fidelity. It can help designers figure out how the product looks like, but it has very low function fidelity. Not only can designers have a model that works like an elastic product, but also have a model that looks like a realistic product. These dimensions of fidelity called visual fidelity and functional fidelity. By varying the model's methodology along these 2 dimensions, models are divided into 4 categories: concept model, appearance model, function model, and final model. We know they have 4 types of models. Now, the problem is which fabrication method should be chosen when designers make different type models. So, let's talk about the fabrication method. There are various types of fabrication machines for designers to choose when they are making models. All the fabrications are divided into 2 categories: digital fabrication and handmade fabrication. Digital fabrication is defined as computer-aided process, such as computer numerical control, rapid prototyping, rapid injection modeling, and so on. CNC machining will produce finished parts from a variety of materials. By cutting parts from blocks of the desired material, it includes laser cutting, milling, water jet cutting, etc. CNC is generally the most accurate prototyping process. It can cut any material precisely and produces strong parts with good surface finish. Rapid prototyping builds model up layer by layer, such as 3D printing, scenario lithography, and fused deposition modeling. Rapid prototyping offers the fastest building time of any additivity process. The process can make parts with complex geometries, and it can also make colorful models. However, most models made by rapid prototyping are rough and weak, and there are very few material options. Handmade model making includes hand tools and conventional machines. Designers need to control tools or machines by themselves. Compared with digital fabrication, this method is slow, but more flexibility. Each fabrication method has its advantages, disadvantages, and unique characteristics. Therefore, choosing a quick and efficient fabrication method to make model is a critical step. So, here comes problems. Which fabrication method is the best choice for one type of model? What factors will influence designers choose fabrication method? What fabrication method designers will prefer to use in different design stages? So, for answering these questions, the objective of this study is to find out the relation between fabrication method and design outcome. The relation features including different types of models, model discrepancy by using different fabrication method to build, and different fabrication method for making model. In this study, the type of model is quantitative and the variable is fabrication methods. Using different fabrication methods to build one type model leads to different design outcomes. Each design outcome can show the feasibility for corresponding fabrication method. 3 questions about the relation between fabrication and design outcome in this study will be answered. 56 industrial design students, both undergraduate and graduate, were surveyed about the method used for fabricate models during the earlier conceptual stage and the late testing stage of an assigned design project. The result shows that most students prefer 3D printing, laser cutting, and manual tools to build models in both stages in their project. The purpose for choosing each method and the level of contribution to the final design outcome will connect. In this figure, students also give a very high score for these 3 fabrication methods. To utilize the most effective fabrication method for the design scenario and discussed. For accomplish this study, one experiment will be completed in the future. 20 students in the same grade who volunteer to be in this study are selected. They need to make a model based on a description. They will be told about what they need to build, include the product, size, color, shape, texture, material, and so on. Participants need to make a model for the product using 3 different fabrication methods, which are 3D printing, CNC, and handmade. The name of each fabrication method should be hidden, and participants assigned these 3 fabrications randomly. After each participant gets their assigned fabrication method, they are asked to finish the survey, which includes 6 questions. In order to understand participants' perspective, the survey can connect data about how they choose fabrication method to make the model, and why. The level of successful for making models. Use preferred fabrication and assigned fabrication will also be evaluated. The surveys will become earlier data. After participants make all the models, later data will be collected. By comparing and analyzing them, the question in this study will be answered. Thank you for your listening. If you have any questions or comments for this study, please contact me.